Hello guys, this is me Nitish VG. I am here to interface with MSP430G2553 microcontroller, and today we will be interfacing with timer module. As everyone knows, MSP430G2553 microcontroller has three types of timer modules, that is timer A, timer 0A and timer A1. These three timers are 16-bit timers, and I have used for today's experiment timer 0. Similarly, in last exercise, in the experiment number 4, I used a delay loop to control the switching time of LED. The same way, I have used here the timer's counting value to delay the blinking of LED between 8 LEDs here, which I have connected in breadboard. The LEDs will blink according to the binary value, and as you can notice that there are 8 LEDs because here I have blinked the LED according to the count variable which is stored in the microcontroller. The microcontroller can store the count value in 8 bits. So while incrementing the count value, each LED will be blinking according to its binary value, and the gap between the blinks is determined by the crystal oscillator, which is used in this development kit here, Q2. That crystal oscillator oscillates in the frequency of 32 kHz. So I managed to make the timer to count exactly approximately near to 1 second between the each blink of the LEDs. So let's see the simulation. Now I am powering on my microcontroller. As you can see, the LEDs started to count in binary values. You can observe that now it is in binary counting, and this continues up to 8-bit count value. The resistors here I have used are 330 ohms resistors to actually power the LEDs. The clock source for the timer is the external clock which I showed, Q2, which is an crystal oscillator. The exact frequency of the oscillation is 32768 or 32768 Hz. And my timer variable will count until 32768 times. So it is exactly 32768 divided by 32768, which is approximately equal to 1 second. So why the each blink between the count variable is 1 second. Now you can see there is a LED blinking in microcontroller's development kit also. Don't get confused because this is an LED which is connected to port 7, that is the last bit. You would have observed that this LED and this LED turned on simultaneously. because both are connected to same port. It is nearing to the maximum value of the 8-bit. In this process, I also resetted the watchdog timer so as to not to interrupt within this process. The count variable, which is the integer data type, the size of the integer in this microcontroller is 8-bit, so it counts up to 8-bit. After this is 8-bit, which is going to near. Yeah. Now after 8-bit, if you further count the count variable, it will actually reset the value to 0, because the maximum value the count variable will store is FF. After FF, it will reset to 00 in hexadecimal, and it will start counting again. So this is all today's experiment. Thank you guys.